All right, last one for this unit. The Hubble Space Telescope was deployed on April 24th, 1990 by the Space Shuttle Discovery. A model for the velocity of the shuttle during this mission from liftoff at t is equal to 0 until the solid rocket boosters were jettisoned at t equals 126 seconds is given by this formula, where velocity is in feet per second. Using this model, estimate the absolute maximum and minimum values of acceleration of the shuttle between liftoff and the jettisoning of the boosters. So, because it has the beginning and the ending here, then we know that t is an element of 0 to 126. And for this absolute maximum minimum, we're going to utilize endpoints. The second thing you have to be careful of is it's asking for acceleration, and it gave us a formula for velocity. So pulling from what we already know, acceleration is equal to the first derivative of velocity, or 0.003906 t squared minus 0.18058 t plus 23.61. Now, because it wants the maximum and minimum acceleration, we're still going to need to derive this formula to find mins and maxes specifically for the acceleration. So I'm going to take a prime of t, and that's going to give 0.007812 t minus 0.1858. 18058, sorry about that. Which means that if this is going to give me, for the critical number, 0 is equal to this, then t is going to equal 0.18058 over 0.007812. I'm going to check my minimums and maximums given my local min or max for my critical number, and I'm going to check it based on the endpoints. So I'm going to look for the y values, and I'm going to first use my critical number and say that the acceleration, using the acceleration, not the A prime formula, is going to be at 0.18058 over 0.007812. And I'm going to put it back into this formula here to actually solve the acceleration. If it's doing it to the nearest hundredth, I'm going to get 21.52 feet per second squared. I'm also going to use the endpoints. And I'm going to say that one endpoint is at 0. And when I sub that in, I'm going to get 23.61 feet per second squared. And I'm going to use the other endpoint when it's jettisoned at 126 seconds, which is going to give me 62.87 feet per second squared. And you can see right here, based on the values, there's my absolute minimum and my absolute maximum. Therefore, the absolute minimum acceleration is 21.52 feet per second squared, and the absolute maximum acceleration is 62.87 feet per second squared. And that's it for this unit.